Alright guys, now that we have made our basic locomotion, let's go ahead and actually code it to our players so that we can test it out and see if it's working. So let's start by using the code from the third person template, right? It'll get us a great starting point. So it's in third person here, blueprints. And remember from the overview lesson how I was talking about how the blueprint holds the logic? And then the animation blueprint holds the animation specific logic. That's what we're doing here. We're creating these. So let's duplicate it. I'll call it BP player. I made a blueprints folder, so I'll just stick it in here. Move here. And then I also want the animation blueprint. You can open it up, and if you see the animation section here, anim class, this is a handy tool on Unreal. Browse to the asset, and then I'm right here. We want Manny though. We don't want Quinn because Quinn inherits all the stuff from Manny. So let's just take from Manny. Call it ABP. Player is fine. And then I also created a folder in the animation called ABP, animation blueprint. So I'll move that there. Okay, great. So let's briefly go over the character blueprint. Let's look at the viewport tab. So here is where you can see what your character will look like in game, and we can swap out the mesh. If you have a specific mesh that you want to use, go for it. I'm just going to switch to Manny, just so the animation, because I animated it on him and I just want to see it on him. That's all we really need to do here. Remember that this is where the movement component is, which has walking speed, it has jump height, it has gravity, how heavy your character is, and all these different things, which when we code it, we'll be getting these values and setting specific numbers. But we'll do that a little later, but just a reminder that that's here. And then the event graph. The event graph is where you hold all the code for your player, all the logic. And we have a great starting point here. We have a few input actions. And then we have our begin play. Begin play is when you press a play button, all this stuff runs. And so what it does here is it gets the input action system, basically the database for the buttons. It gets that and it adds it to the player. So we'll actually go ahead now and create all our own buttons. Right now, since we're just doing the walking and the running, let's just do the camera and the movement input. So we'll reuse all of these, but just swap out these here, which are the separate buttons. So let's go ahead and create our input actions. There are going to be two specific assets we need. We will need an input mapping context and then all the individual input actions. So let me go ahead and create a new folder, input. Let's create a new folder, call it actions, and this will store all our actions, like jumping, attacking, dodging, all that stuff. And then again, we need our input mapping context, which basically defines the button that's being pressed. How the button is being pressed is going to be the actions there. So let's do input mapping context. I just name it the name of my project. I name them after Elden Ring characters because why not? And then let's go ahead and create some actions. So again, same thing. It's under input action. I'll do it IA, and then underscore. We want look, and then let's double click to open it up. So for looking around, it's just controlling the camera, and the camera isn't really a button, right? It's just moving your mouse around. So we don't want digital bool, which is like you press a button and it means it's on, and when you release the button, it's off. We don't want that Boolean either or. We want a different setting, which is axis 2D, vector 2D. Think of this like a grid. So let's just switch that, and that's all we need to do for the input action. Now let's create our moving one. So again, input action, IA, move. Okay, and for moving, same thing, we move along a grid, right? We don't want the button to be either or. So let's just switch it to axis 2D, vector 2D, and then we're good to go for that. So the actual implementation of the button behavior is going to be in the input mapping context. So if we go here and we add a mapping, look at this. We can then select IA, look at that. So then for doing the looking, we need to assign the button, which will be, if you go here, you can do mouse, and we want mouse, let's see, what is it? XY, which is the horizontal and forward, not up and down, right? 2D axis. So that's our grid. And then what we want to do, if we go here to modifiers, this basically means the direction of your grid. We want to negate it because we want it to follow the way games normally do, which is where when you move the camera, when you move your mouse to the left, the camera moves to the left. And then I also like to add it for controllers as well, so gamepad, and look at all these options for the buttons. So we'll be using a bunch of different these, and I actually have a photo in the link in the description which tells you what all the different buttons mean, like what is right shoulder trigger, you know, that there's an image down there that'll be helpful for you, so download that. Basically we need the right let's see, looking around, you control that with the right thumbstick, and we want right thumbstick 2D axis. And same thing, we want one modifier, which is dead zone. And I think this has to do with preventing like drifting on your controllers. That's that. And then let's go ahead and add the moving. So do this, IA underscore move. Wonderful, now we have our movement, and for moving around we can do WASD, you can do the arrow keys, and then we will do the gamepad. So let's add a bunch, 1 2 3 4. So let's do W, which is going forward, we'll do S, which is going backward, A, which is going left, and D going right. So let's do the same thing, add modifiers. So there's this thing here, swizzle input action values. It's basically defining our grid. So W, we want to go forward, and we want backwards to also do the same thing. We want it to swizzle, but then we don't want it to go the same way as the W, so we add another one to negate it, and that way we can move along that one axis, or that one axis, excuse me. And then for A, going left, we just want to negate it. And then this one we can leave blank because this one is the other direction of the axis. So we can go ahead and do that for the arrow keys if you want. For now, I'm just going to ignore it and add them later. It's fine. Gamepad, let's do the left thumbstick 2D axis. And then same thing, we need the dead zone to prevent drifting. And then we need this one called scalar. Okay, great. So that's how you set up generally your input action. So we will do the same thing for attacking, dodge rolling, healing, all that type of stuff. But it doesn't really do anything unless we actually implement it in our player, which we'll just steal all this stuff from the template, but just replace our input action. So let's go ahead and do that now. If you right click, I can type in IA underscore move, and you'll see my one that we made comes up, which is great. We'll be going into more detail of what's triggered, started, ongoing, canceled, all that stuff. But for now, let's just do triggered. This means that it keeps evaluating. It'll keep in a circle, it'll keep checking, versus started is more like it just does it once when the button is pressed once. This here controls the grid again, what's forward, what's left, what's right. And for us, all we really need to do is connect the x-axis. Oops, I forgot to split it. You need to split it to get to get a grid, right? Split spin structure. And then we want the x to go into this one here. And then we want the y to go into this one here. Okay, great. So we've implemented our moving. Now let's do the camera. We can do the exact same thing. Let's just swap out for our own input action. So IA underscore look. That's why I named them all caps, so I know which one is mine and which was the template. But anyway, okay, same thing. We will do triggered, connect that there. And then we need to split it again so we get our grid, split spin structure. We'll put the X in here, and then we'll do the Y in this one. Okay, great. So we should be good to go there. Now let's actually dive into the animation blueprint, since that is where we'll really be implementing all our animations. Okay guys, so I have the third-person character animation blueprint open here, and the reason why I have this one is because I did it freaking again. I recorded talking about all this stuff with my mic muted. Sorry, I'm not used to the PC workflow because I just got a new computer. So I will show you kind of what it started with and the very small thing that I changed, and then I'll resume talking about what all these different nodes mean. So first you have event blueprint initialize animation. This is essentially begin play. And what this does is it gets a reference to the character. And so right now it casts a character, get owning actor, it sets it. I swapped that out. So in the main one that I set up here, you'll see that I did like a hard cast to BP player, which is the one we have. And the reason why we need to cast is because we need to get all the information from the character movement component. Remember, the character movement component has all the different parameters for walk speed, jump height, velocity, all the different like Unreal's code of how it handles movement. We need access to that in here in order to get our animations to play depending on whether we're jumping or whether we're running really fast and all that stuff. So that's what you do here. You cast to it, and we want to have this player reference so it's easier to code, and we can just pull it from the variable section here. So what you do is you right click and you'll see the option here, promote to variable. I already did that. And since this variable is essentially a reference to this blueprint here, what we can do is we can drag off and get the character movement component. So this little node right here is a reference to this here. So we will be able to get all of the information here. Now, a key link to understand between your animation blueprint and your player blueprint is when we actually go to code the transitions between all the different states, you can't just drag the player reference here. Unfortunately, when you go to the anim graph and you go to like all these different states and stuff, this only takes animation blueprint variables here. It does not take the referenced player blueprints. So an easy way to work around that is we just create our own variables here that we link to the variables in the player blueprint. So that's why we grab the character movement component, and then you'll see that there is a variable here, type character movement component, and then we just set this to be this, so that we have this link here to then have access to all of the different information. So this is this new variable that we created inside the animation blueprint. It's only in here, it's not in here. This is essentially like a second reference. It's down from the hierarchy of this. So that's what we're going to be doing for a lot of our logic for entering into different states. We'll go into it more specifically when we get there. But another thing I swapped out is this here. So I have the player ref, and what you do is I wanted to swap it out to the character, right? So if you get it, you can right click, do convert to validate get, and that's how you do this. This basically is just a nice check, so you remove potential errors in code. And then because we have that player ref, we have the ability to grab all the different stuff from the character movement component again, and we can set different parameters. So in the third person template, Unreal already has some that we can just use, and it works right out the gate. So it sets the ground speed here, again, movement component, look, it got the velocity, and then we coded our own velocity node here. So the movement component velocity is the same as this velocity, animation blueprint velocity. And then we set the ground speed. Same thing, it does this should move thing to avoid having small movements trigger larger animations. And then same thing here, it has falling, which we'll use for jumping. And just to make this super clear, look what I can do. I can get my player ref, so now I have a reference to it. I can go to my player here. Look, I'll create a variable and I'll call it your mom. Look at that. Compile it. Now if I go back to here, look, I can drag off because this is referenced and I compiled, so it should be updated. I can get your mom. Look, I'll get it. And then because I can't code your mom directly in all the state machines, right? What I have to do is then create another variable, and we'd name it something similar so we can keep track of what's what. We could call it like your mother, and then we would set it to be we would set it to be exactly the same. So this is how we reference. We get the reference of the character blueprint. We drag off it and access its specific variables, whatever they are, whether that's the movement component, whether it's a specific boolean we set on, whether they're, with the player is strafing or whatever. And then we create our own animation blueprint specific one named similarly so we can keep track of what's what. And this is what we'll be using in all of our anim graphs. So, okay, and that's about it for the event graph here in the main animation blueprint. Now let's actually go ahead and talk about the anim graph. Alright, now this is the last part, and the part I find the most fun anyway is doing, this is what houses and where holds all the animation. So I do want to clarify something at the beginning. Remember in the overview lesson I said that animation montages are stored in the character blueprint? That's a little bit oversimplified, so while we will be doing the timing of them here, so you could drag off and trigger an animation montage here, it will not play unless you have a default slot. So everything at the end of the day does go through this animation blueprint, but the actual montages and the timing of when they occur within the code is not actually held in the animation blueprint. It is held in here, but it will not play unless there's a default slot. So that's what this is. And let's look at these little things here. So this is your state machine. So I didn't have too hard of an understanding of these. Basically, you think of them as animations and transition animations, which I view as breakdowns. So you have your jumping up here. So this is an animation asset. This is an animation asset and transitions. And then look at this. There's locomotion here. And it is using a reference to another state machine so that you can work more cleanly. So let's actually go ahead and load this locomotion state machine. Aha! And here is where we have all the implementation for walking, running, your idle. So if we double click it, this is where we plug in all the animations. We just drag and drop in here. So we can swap them out. Idle. I will do my idle that I did. Boom. So look at this, I'll delete it, compile, and there is my character in the idle. So that is great. Now I can go to the walk run. And you'll notice here, the walk run needs two different animations, one for walking, one for running. And this is where the blend spaces come in. Remember those assets that hold a group of animations together? Because all of the walking, running, sprinting, those are in this type of state, this group of animations. And so let's actually create our own blend space. You'll see this is the one that comes with the template. So this is walking for when you press the thumbstick and you're going at really slow speed. If I hold, I think it's Alt or is it Control? No, it's Control. Then I'm walking. And then I can move along, and then I go running. So let's go ahead and create some blend spaces. All right, so let's create that blend space that holds all our run and sprint animation. So if we go to animation, you'll see there is blend space. However, this is the blend space that has more details in it, like more axes, which we'll use for strafing, because you want to strafe forward and back and left and right, but we don't want that right now. We just want one. And so if we go to legacy, then you see the 1-axis version. So let's do that. And you need to select your skeleton because all the animations are tied to a specific skeleton. If you want to use these animations on a skeleton that's different, say it has a different naming convention or different placement or even different additional joints and stuff, you'll need to retarget. But since we created our animations with Manny, right, we can just use the Manny one. So I'll call it blendspace run, and I'll double click to open it up. And you'll see it looks just like this one here, but there's no animation. So if we need to add all our animations along this one axis here. So the horizontal axis, let's call it speed because this is the movement speed. This is really just for us. Unreal, you could literally call it like your mom and it'll function the same thing as speed, but for us, we want to call it speed so we know what we're doing. And let's also add extra grid subdivision just so the math is a little bit easier, and snap to grid. This just means when we drag and drop our animations in, see idle, it'll snap at 0 instead of being at like 0.0014 or whatever, because we don't want to deal with that. And then I'm going to delete that because I actually don't want it. And then the minimum axis value and the maximum axis value. These are the numbers that we want to correlate with our walking speed in the character movement component. So let's do the maximum axis value. I'll just do 600 because when you're sprinting, I want them to move at 600, which centimeters per second. I don't know, I'm an American. Give me it in like feet and then I would have a better idea. But whatever that is. Maybe Europeans have a better idea. And then let's also do the minimum one, which I'll do 100, I guess, is a good walking speed. I don't want 25. Hold on, I want 5. Okay. And now let's drag and drop our animation. So we want the walk. Where is the walk? Here it is. Drag it, and it'll snap at 100. Yay! There's the walk. And then the run, I want it to be at 500, which is here. If I hold control, see I get this little green X, and it shows me the character moving and blending through the animation. So this is the power of blend spaces. Look at that. Woohoo! And then let me add the sprint at the very end. Ta-da! Woohoo! Look at that. So nice. Okay. And I believe that's all we really need here. So we can go ahead and save it. And then back to our animation blueprint. Let's replace the old walk run that came with the template and do it with our new one. And then we want to connect the ground speed because, again, remember we had that axis here, this thing, speed, and we called it speed. But now we just implemented the speed. And now it knows, it gets whether it's in 100 and 500 and all that stuff from here, which again, if we go back to here, it's all based upon the movement component, the character movement component, the velocity, ground speed, all that stuff. So we have just connected the movement here into our blend space. So that's how all that works. If it doesn't totally make sense right now, it'll make sense in practice, and as we go along in this course, you'll get more practice at it, so it'll make sense. So let's compile, and that's great. So we can go ahead and press play and see how it looks. And when you press play, you'll see what? It's still Quinn. What? That's because there's another level specific code we need to write, and it's actually really easy. So you'll see how in the world settings for this specific level, it's using the third person game mode. So if we browse to it and open it up, you'll see that the default character, the pawn class here, is the third person character, and that's why it loaded Quinn, right, and not our own character. So let's switch that over to BP player. And I also remembered I totally forgot to switch something over. So very, very important, guys. We need to switch the input mapping context to the one we made and not the default one. Otherwise, none of it will work. Okay. So now let's just save everything. Save everything. So in case Unreal crashes, we are okay. Press play. There's my idol. Looking at it, see, this is why you want to test in game. He looks really bow-legged. Like really, really bow-legged. I do not remember. Huh. Yeah, like that foot. That foot is definitely further back. Hold up. The animator in me is like, sirens are going off, all this stuff. Yeah, that's what the heck. All right, I'll have to troubleshoot this and let you all know why. Why is it doing that? So weird. Is it doing that? And yeah, there's something whacked up with that foot. Yeah, it's totally messed up. Look at the toe and everything. What is this? I wonder if I disconnect the IK, does this do anything? Aha! Interesting. Okay, guys, I will figure out a fix for this. But for now, I'm just going to disconnect it and try it out. I'll report back on that. Okay, now he's not that weird bow-legged thing. Sweet. Now if I press forward, he's running. And I don't have my controller connected, so I can't show the walk. So let me go ahead and do that. Okay, I have my Xbox controller connected, and if I do the stick a little bit, he starts walking. And you can see already that the speed could be improved. It's a little messed up, and he's popping around and a little hitchy. We will sort all this out, and you can see this run here does not match the speed. I can't tell if it's like too slow or too fast. It also looks weird because I don't have the weapon. I haven't added that yet. So yeah, but look at that. Look how fun it is. Alright, so the next thing we need to do is to set up our input action logic in the character blueprint to actually run when we hold the button to run, because we haven't set that up, and that's why we can't see him enter into our sprinting state. And then I'll also spawn a weapon so that he actually holds it. So let's go ahead and do that next. Okay, so for doing our run, we need to do an input action. So let's go to our input actions, go to the input action, and let's call it run roll, because we'll be doing like all Souls games. You hold the button while you're moving forward and you run. If you tap it while you're moving forward, you dodge roll. But if you tap it while you're standing still, you step back. So let's go ahead and set that up. Okay, so this time we do want the digital bool because we want it's a button to be either on or off, and we will add some triggers. So this is a good time to talk about triggers. If you look, you can see there are all these different options. There's like hold, press, tap, all this stuff. So let's think about it for Souls games. When you hold it, you run. So that's what we want to add, that one. And then we'll add a hold and release. And I think that should be good for that. So save it. And what do we do next? We got to go to the input mapping context to assign the button. So as always, add it up here. Gonna make those smaller. And then we select it. IA, run, roll. Let's see. I think it's Alt, right? I don't play PC games, so I normally do controller. But controller, oh my gosh. Stop that. It is going to be the gamepad face button right. That is normally the button for dodging in Souls games. Where is it? Face button right. Okay. And save it. Awesome. So now we need to implement our input action. So we can go down here and do IA_run roll. So we will be doing a lot more in this action once we actually animate our step back and our dodge roll, and we'll tie a stamina system to that. But essentially what we need to do is when we hold the button, we edit the max walk speed and we change it from 500 to 700 or to 600, whatever I set it in the blend space there. And a nice way to actually handle this is by using components, a blueprint component. So let's go ahead and do that. In blueprints, you can right click here, blueprint class, and you'll see actor component. Excellent. And then we will call it BPC, blueprint component, and I'll call it stamina. So open it up. Now think of components like attributes that you can code and then apply that code to many different types of characters. So for example, we can code stamina functionality here, apply it to our character, but say we wanted an NPC or a boss enemy, and Souls games don't typically use stamina for other characters, but in the case that you would, then we could just use all of the logic for stamina and apply it to them rather than have it all hard-coded in the player. So create some variables here. So let's do the walk speed. So let's do walk speed. And speeds are not booleans, right? Because booleans are either or, yes or no. We don't want that. We actually want float, which is a number. So that'll be good for that. We can control D to duplicate it, and then we will have run speed. Great. Duplicate it again, and then we have our sprint speed. Awesome. So now we have these three here, and we can go and compile, and look, now we actually can type it in our stuff. So what did we do for the in the blend space? 100 for the walk, run I did 500, and then sprint speed I did 600. Okay, great. So let me compile this, save it, and let's add this blueprint onto our player. So let's compile, save. You see here, you can go add in the component section. And if I type BPC, look, it comes right up, and I'll just leave it like that. Okay, so now that we have all the walk speeds that we set, the blueprint component, we can get them from here. So we want get sprint speed, which we know the sprint speed, as you can see, is 600. And what we want to do is we want to update the max walk speed. So get the character movement component, all right? Because remember, this holds all the movement information. So we need to get the information from here. So set max walk speed. And then instead of typing in hard numbers, we will just use this 600 that we made from here. Keep things more clean and organized. It's generally better that the more you can find ways to have things be more flexible like this than hard code it in, usually you have an easier time. So when we press the button and hold it, this is what happens. The max walk speed, the character moves faster, so that is great. However, we also need to make it so that when the character releases the button, the speed resets and it goes back to 500. Because right now, if we do it, which I'll show you, normal. Okay, great. Now if I hold the button to sprint, oh, that's fun. My speed doesn't match. See, it's too slow. My feet are sliding. But again, I'll adjust these things. And I let go. Okay. And now he's running again because we didn't reset the speed. So let's go ahead and do that. Okay, let me open this back up. So what do we want to do? We can do on completed. So what we can do is get the character movement component again. We can do set max walk speed. And instead of hard coding it, what can we do? We can drag from our status our blueprint component, and then we can get the run speed, and then we can plug that in and then connect completed with that. Okay, so compile it, save it. Now it should work. If I press play again, also I will point this out because it stumped me and it took me like 3 hours to figure it out. If you're pressing buttons and you're like, oh my gosh, my character's not moving, WASD, what's wrong? All my input actions are wrong. No. Click for mouse control. You have to click it and then everything should work. You can edit that functionality in code, but for now, we'll just leave it. But anyway, okay, so he's running. If I hold, then he sprints. If I let go, all right. If I, yay! See, now it works. Holding it, and he goes into the sprint. Nice. Let go, run, hold, sprint. Awesome. We need to essentially spawn the weapon on the player. And we need an actor in order to spawn it. So let's go to blueprint class, make actor, and I'll call it BP Rapier, because this is my sword. We will be overhauling this later in the attack section, but it's a bit more involved to set that up, and I just want to keep it simple. So what we'll do is we'll just do this and replace it later. And let's add our mesh. So I believe mine's a skeletal mesh, so I'll do that. And I'll call it rapier. And then here I can select it. So rapier, there we go. Awesome, compile, save. So back in the player, let's do another thing, which is a custom event. So type in custom event, and we'll call it, we can just do spawn sword. Again, we will be overhauling this later once we get to the combat section. So we just keep it simple for now. So let's do spawn actor of class. Spawn actor from class. And we can do BP, what did I call it? Sword or BP rapier. Awesome. And then the spawn transform, we want to spawn it to a specific location on his hand. Think of it like a locator that you parent into your rig. That's what we want. And if you follow the tutorial for constraining props to your character, you'll know that you set up a socket. Like that's how I've been doing it in my animations when creating it, because I created a socket here for the sword. Here, so we will just spawn it at that location, and it should align. So we'll get the spawn transform. Let's do get socket transform. And then we can just type in the socket name. So let's copy and paste it to avoid errors. Control C, Control V, and then we need to specify the target mesh, because right now Unreal has no idea where this socket is. So luckily it's in Manny, which is right here. So I'll just do that. And then we need to attach the actor to a component. Attach actor to component. The target is going to be the sword here. And then the socket name, again, is the socket name. Okay, right. And then the last thing is we don't want keep relative, we want snap to target. Okay, so now we have the logic for spawning our sword, but it'll never take place. Custom events never take place unless you tell Unreal to do it. So let's just do it in begin play. Let's go up at the beginning and let's see what we can do, because we'll probably be adding stuff later, is we'll extend this, do sequence. So first thing when it begins play, it'll do all the input mapping context. And then after that, we can have it spawn our weapon. So we can spawn sword. And then now that custom event is called, so it'll actually take place. So if I go ahead and press play, yay, there's a sword! Now I can run around and swing my sword. Woohoo! Yay! Okay, this is awesome. Alright, so I don't know about you guys, but the first time I animated my character and then applied it in game and I saw him moving around, like, it was just such a satisfying feeling and I loved it. So I hope you're having fun and learning and are satisfied with seeing your characters come to life. And yeah, we will go ahead and do the jumping next and also add transitions, because I don't like how mechanical this is with his arm. I'd want to essentially create a state in my state machine that functions as a breakdown between running and idle, and I'll probably tweak a little bit of the animations too, because he's too up and down here. I need to reduce the TY in the shoulders and the chest. So yeah, that's all I have for you today, guys. I'll see you in a bit.